Alright, so 1.4 is identifying functions. This is the second video from 1.4. We talked about functions a little bit earlier. We talked about it's a relation that relates, which is kind of redundant again, a set of input values, which we like to call domain, which are x variables, so two parentheses there, to a set of output values, which we call range, or which we use the y variable for usually. And again, we're trying to use, instead of using y, we're trying to use this f of x notation. And here's the other thing about functions I was thinking about. Just because there's a relation doesn't mean there's a pattern or anything to them. Sometimes it's just like a random set of occurrences. So you'll have like a couple different ways that we write function stuff. So you'll see these things with the fancy brackets, and you might see like a point, so like x1 comma y1, and then you'll happen to comma in the middle, and then you'll have another point, x2, and then like a y2, and then you'll have like a whole bunch more until you finally get down to like x to some number n and y to some number n that make up what's called the set, which is just the group of numbers of domain and ranges of inputs and outputs of x's and f of x's, or x's and y's, that make up this thing. So this is what's called set notation, because it shows you the set and their pairs with it. It's good. I like set notation. As you go further in math, this is the kind of thing you're going to see. But the other thing I really like to see is a thing called a mapping. And basically it's a map, right? So just like how you get from home to school or whatever else, x1, x2, all of your domains are going to go on this left box. So I'm just going to label these domain. And it's kind of a circle or a box, whatever you're feeling. And all the ranges, all your output values are going to go in the y ones. And it's called a mapping because we know that x1 is paired with y1, so they're going to draw an arrow that goes only from x1 to y1. We're not going to draw the arrow going backwards. x2 is going to go to y2, and on until you have a list of all of your input values going to all of your output values. So here's the fancy thing about being a function. A function says that for each input value, each domain has one range value, and this is really kind of important. Think about it like a Coke machine, right? You walk up, you push the button for X1 or Coke. If you push that button over and over and over, you're pushing that same domain, you should always get the same thing popping out of the machine. If it's not the same thing, then something's broken about it. That machine is no longer functional. So the question we're going to ask a few times, is the relation a function, and why or why not? So we have this in set notation. We've got the point 1, 4, negative 2, 12, and 3, 9. And you can always put things in point form. You know how to pull points from a graph. So looks like we have 1 goes to 4, negative 2 goes to 12, and 3 goes to 9. And there's not really a pattern here, and that's okay. Like I said, we don't need to necessarily have a pattern. So I could draw the mapping if I want to. I think that helps to organize my information a little bit. So I've got my domains on the left and my ranges on the right. I notice that 1 goes to 4 every single time. There's no other 1 going at any other number. Negative 2 only goes to 12. So like Coke goes to Coke, Diet Coke goes to Diet Coke, and Sprite goes to Sprite. And there are no repeats. So if it asks, is the relation a function, then yes, it is a function. It's a function because each domain has only one range. Okay, so let's look at example 2. So example 2, we've got a couple different numbers in here. So we've got 0, 5, 2, 9, and 0, negative 4. So again, I'm going to draw my mapping. So my domain, I've got 0 and 2, and another 0. So I'm not going to draw another one. I only need to list it once because I can draw multiple arrows. So my range values, I'm going to have 5 and 9 and negative 4. Okay, so we're making our mapping. So 0 goes to 5, 2 goes to 9, and 0 goes to negative 4. And this is the part where functions are not, this is not a function, so this is just a relation. It's just saying you have some numbers going to some other numbers. And again, there's not a pattern. Because 0 goes to 5 and to negative 4, it'd be like a Coke machine, being like, alright, press the button for Coke, and you get either a Coke or a Diet Coke. That's not really cool. So no, this is not a function because 0, and you can say 0, let me write 0 so that's clear, has 2 range values. You get a random thing pop back. Okay, so we talked about set notation, we talked about mappings a couple times. We also have the traditional graph, and you can either have graphs that are in straight lines or graphs that are just points. So I listed the points out. I'm going to write these points down in set notation first just to see if I can make sense of it. So I got 0, 0. I've got 1, 1. I've got 3, 3. And there's not really an order. I'm just kind of picking them as I find them. And 4, 2. Let's see, put a comma in there. And close with a fancy bracket as well. So now they're written in set notation. We're checking to see, does each input have only one output? Okay, so 0 only appears once. So yep, we're good. 1 appears only once for our input values, so we're good. 3 appears only once, and 4 appears only once, and it doesn't matter what their output is. They can have whatever random output it is. Like I said, that function doesn't necessarily have to have a pattern, or that relation doesn't have to have a pattern. It just doesn't have only one output for one input. So yes, each input has only one output. So each domain has only one range. That's what we're looking for. So here's the other thing we can do when we have graphs, which is my favorite thing. If you remember, our input values are a set of all of our x values. Our outputs are all of our y's. So we can use this thing called the vertical line test, which says you take a vertical line, such as a pencil or a pen, and as it goes across your page, let me use a smooth side, each time you have an x value, you should only have one output. You shouldn't have multiple points. Each time you have an x, you have only one point. Each time you have this x for a 3, you should only have 1 point. Each x should only have 1 point, which says that the vertical line test says if there are more than 1 points on a vertical line, then it's, okay, not it, that's bad. We should use something a little more specific. And that's a little bit far down. Okay, if there are more than 1 point on a vertical line, then the relation is not a function. So I'm just going to mark this off because it's kind of a big deal. Vertical line test. If there are more than 1 point on a vertical line, then the relation is not a function. Because as you go across, you should only have 1 point for each output. So only 1 point, 1 point, 1 point, 1 point, we're good. So let's use the vertical line test on number 4. So we're going to go across. It looks like we have, here's a problem. -3 has 2 outputs. It's got, looks like 1 and it's got 4. So we can say, no, this is not a function because it fails the vertical line test. And make sure that you can write that out and explain that if you need to. Okay, I'm going to have a practice page for this, so make sure that you grab this and also the one for evaluating functions. And then that's all of 1.4. Just make sure you're good for that, and you can take